Good morning, students. This is Mrs. Sati Joseph, your science teacher. Welcome back to the online teaching for the session 2020-21. Let us continue with the same chapter, that is chapter 11, Force and Pressure. In the previous module, we had discussed about non-contact forces and its examples. What is non-contact force? Non-contact force means the force which can exert by an object on another object when they are not in contact. Electrostatic force, magnetic force, and gravitational force are examples for non-contact forces. Today, in this module, I'll explain what is pressure. Also, we will see whether liquid and gases also exert a pressure on the walls of its container. We will discuss about atmospheric pressure also. Let us see the first topic, that is pressure. In class 7, you have learned that strong winds during a storm or a cyclone can blow away even the rooftops. You also learned that winds and cyclones are caused by the difference in air pressure. Let us find out, is there any relation between pressure and force? Try to push a nail into a wooden plank by its head. Did you succeed? No. It is difficult to push a nail into a wooden plank by its head. Now try to push the nail by the pointed end. Could you do it this time? Yes, you could do so. It will be easy to push a nail into a wooden plank by its pointed end than its head. Can you say which is easier, cutting the vegetables with a blunt or a sharp knife? Yes, it is easy to cut the vegetables with a sharp knife than a blunt one. Can you explain why it happens so? Why it is easier to cut the vegetables with a sharp knife than a blunt one? Or why it is easy to push a nail into a wooden plank by its pointed end than its head? Okay, I will explain. In the case of head of the nail or a blunt knife, the area of contact is more. So the force which is applying, that will be distributed. The other case, in the case of a pointed nail or a sharp knife, the area of contact is less. So more force will be applying. So we can define pressure as the force acting on a unit area of surface. What is pressure? The force acting on a unit area of a surface is called pressure, or in other words, we can write pressure is equal to force upon area on which it acts. Which means the smaller the area, larger the pressure on a surface for the same force. Here, area of contact is given as the denominator. That means if the area is less, then pressure will be more. And if the area is more, pressure will be less. Now, can you explain why shoulder bags are provided with broad straps and not thin strap? Yes, it is because if the straps are thin, more pressure will be acting on your shoulders. In the other case, if the straps are broad, then less pressure will be there on your shoulders. Do liquids and gases also exert pressure? We will do one activity. Take a transparent glass tube or a plastic pipe. The length of the pipe or tube should be about 15 centimeter and its diameter should be 5 to 7.5 centimeter. Also take a piece of thin sheet of good quality rubber, say a rubber balloon. Stretch the rubber sheet tightly over one end of the pipe. Hold the pipe at the middle, keeping it in a vertical position. See the figure. Ask one of your friends to pour some water in the pipe. Does the rubber sheet bulge out? Yes, you can see that the rubber sheet bulge out. Note also the height of the water column in the pipe. Pour some more water and observe again the bulge in the rubber sheet and the height of the water column in the pipe. Repeat this process a few more times. Can you see any relation between the amount of the bulge in the rubber sheet and the height of the water column in the pipe? Yes, if the height of the water column increases, the bulging of the rubber sheet also will increase. So from this activity, we can understand that pressure exerted by water at the bottom of the container depends on the height of its column, which means as the height of the water column increases, the pressure exerted by the water at the bottom also will increase. So there will be a change in the bulging of the rubber sheet. Another activity is given in your book. You just go through that one. Activity number 9. I will explain one more activity. That is activity number 10. Take an empty plastic bottle or a cylindrical container. You can take a used tin of talcum powder or a plastic bottle. Drill 4 holes at around near the bottom of the bottle. Make sure that the holes are at the same height from the bottom. Now fill the bottle with water. What do you observe? Is the water coming out of the holes at the same distance from the bottle? Yes. The different streams of water coming out of the holes fall on the same distance from the bottle. This indicates that liquids exert equal pressure at the same depth. If the depth is same, then the liquid exert equal pressure on the walls of the container. Now, can you say that liquid exerts pressure on the walls of the container? Do gases also exert pressure? Yes. Liquids and gases exerts a pressure on the walls of their containers. When you inflate a balloon, why do you have to close its mouth? What happens when you open the mouth of an inflated balloon? Suppose you have a balloon which has holes. Would you be able to inflate it? Can you give the reason? Yes, it is because if there is a hole, the air will go out through that hole. If you open the mouth of the inflated balloon, that case also the air from inside the balloon will go out through the mouth of the balloon. So we can say liquids and gases also exert a pressure on the walls of their container. Like a liquid, gases also exerts a pressure on the walls of the container. Let us see what is atmospheric pressure. You know that there is air all around us. This envelope of air is known as the atmosphere. So what is atmosphere? The envelope of air around us is known as the atmosphere. It extends up to many kilometers above the surface of the earth. Then what is atmospheric pressure? The pressure exerted by this air is known as atmospheric pressure. The envelope of air around us is known as atmosphere, and the pressure exerted by atmosphere or by this air is known as atmospheric pressure. So what is pressure? Force per unit area is called pressure. If we imagine a unit area and a very long cylinder standing on it filled with air, then the weight of the air in this cylinder is the atmospheric pressure. What is atmospheric pressure? Imagine a unit area and a very long cylinder standing on it filled with air. Then the weight of the air in this cylinder is called atmospheric pressure, or that will be equal to the atmospheric pressure. Now let us get an idea about the magnitude of atmospheric pressure. Magnitude means how large or small is the atmospheric pressure. We'll do one activity. Take a good quality rubber sucker. It looks like a small rubber cup as shown in the figure. Press it hard on a smooth plain surface. Does it stick to the surface? Yes, it sticks to the surface. Now try to pull it off the surface. Can you do that? No, it will be difficult to pull it out. Why does it happen? When you press the sucker, most of the air between its cup and the surface escapes out. The sucker sticks to the surface because the pressure of atmosphere acts on it. I'll explain. When you press the sucker, most of the air between its cup and the surface will escape out. Then what happens? Because of the pressure of atmosphere acts on it, the sucker sticks to the surface. There is atmospheric pressure around the sucker. Because of that, it sticks to the surface. Now to pull the sucker off the surface, you have to apply a force which should be large enough to overcome the atmospheric pressure. If you apply a large force, then only you will be able to pull the sucker out of the surface. So this activity will give you an idea about the magnitude of atmospheric pressure. How large is the atmospheric pressure? It would not be possible for any human being to pull the sucker off the surface if there were no air at all between the sucker and the surface. If there is no air at all between the sucker and the surface, it would not be possible for any human being to pull the sucker off the surface. I think now you got an idea about how large the atmospheric pressure is. The weight of air in a column of the height of the atmosphere and area 10 centimeter into 10 centimeter is as large as 1000 kilogram. The weight of air in a column of the height of the atmosphere and area 10 into 10, that is 100 centimeter square, is about 1000 kilogram. If atmospheric pressure is this much high, then why we are not crushed under this weight? Can you say? It is because the pressure inside our bodies is also equal to the atmospheric pressure and cancels the pressure from outside, which means from inside the body a pressure is acting in the outward direction and there is atmospheric pressure acting on us in the opposite direction. So these two pressures are equal and opposite. That is why they cancel each other. So we are not crushed under this weight. Is it clear? So this is the end of this chapter. I hope you all understood the topics. Have a nice reading. I'll give you the notes in the next class. Till then, thank you, bye bye, and take care.